Having learned how to add, subtract, and multiply polynomials, you may be wondering why we haven't learned how to divide them yet. The answer to that is that polynomial division is kind of a long subject, and so we're postponing it until we need it a little bit later on. However, there is one kind of polynomial division that we'll find useful to have available to us now. And this method of polynomial division involves essentially the same process as we use to factor, except that one of the factors is given. Although we can use this method for any polynomial division, it's easiest to use when we're dividing by a linear binomial and there's no remainder. So that is, when we're dividing by a linear binomial factor. So for example, here's a division problem that this method will work well for. Here's an example of a polynomial division problem. Notice that both of the polynomials are in parentheses to indicate that the entire first polynomial is being divided by the entire second polynomial. And I should note that before I do this, I'd like to have each polynomial written in descending order. That is, so that the degrees of the terms decrease as I go from left to right. We can check quickly that the first term is a factor of the first term. Clearly, x goes into 2x cubed. And the last term is a factor of the last term. Clearly, 3 goes into 6. And the reason that that's useful to note is that our divisor then at least has a hope of being a factor. Remember that when we multiply out, no addition happens in the first term or in the last term. So we're going to attempt division using this method. How do we do it? We start to set up the frame that we would use to factor, but we only set up the first column. We also know that x minus 3 is one of the factors, so we'll write that to the left. And then to get started, we're going to put in our 2x to the third. Okay, now what? Well, we know that the only way we get 2x to the third when we multiply, remember, we're just winding multiplication backwards. The only way we'll get 2x to the third when we multiply is by taking something times x. What times x gives me 2x to the third? Well, 2x squared gives me 2x to the third, which means I'll also have to multiply 2x squared times negative 3, which will give me negative 6x squared. For our next move, we'll remember that when we multiply, our like terms appear along the diagonals. So I'm going to be introducing another column. And to decide what number goes up here, I'm going to say, well, my x squared term, I'm going to write my x squared term underneath here. My x squared term needs to add up to negative 9x squared. So I'm thinking negative 6x squared plus what gives me negative 9x squared. And if I like, I can do subtraction to find that out. Subtraction always gives us the missing number in addition. What I need here is a negative 3x squared. So I'll fill that in. Okay, so that's it for that round of division. Just like long division of numbers, this proceeds in several rounds. Now I'm going to look at my negative 3x squared and say, what do I need to multiply by x to get negative 3x squared? I need to multiply by negative 3x. Then I need to also multiply the negative 3x times negative 3. That'll give me a positive 9x. Now, my like terms with an x in them are going to live on this diagonal. So I'm going to have another column. My x term is 11x. And I'm going to think 9x plus what gives me 11x? Well, to figure that out, I'm going to say 11 minus 9 is 2. So I need a 2x here. That brings me to the end of that round of division. Next, I want to think, what do I need to multiply by x to get 2x? Well, positive 2. And then 2 times negative 3 is negative 6. I want my constant term to be negative 6, which it is already. So that x minus 3 really was a factor. That is, if I take x minus 3 times the result I just got, 2x squared minus 3x plus 2, I get my original dividend. And therefore, because division just reverses multiplication, when I take my original polynomial divided by x minus 3, I get 2x squared minus 3x plus 2. I'm going to do another example, now just showing you the method, without any of the discussion of deriving it. And then I'm going to have you try one. Here we're dividing 6x to the 4th minus 11x to the 3rd plus 8x minus 3 by 2x minus 1. Now you may be noticing something odd about this polynomial, namely that it doesn't have an x squared term. For this method of division, that's going to be fine. We'll see what happens here. So I'm going to start by setting up just the first column of a frame as if I were going to factor, and I'll put my leading term, my 6x to the 4th, in the first box. Okay, now what do I need to multiply 2x by to get 6x to the 4th? Well, I need to multiply it by 3x to the 3rd. Now I multiply 3x to the 3rd times negative 1. That'll be negative 3x to the 3rd. Okay, I need a negative 11x to the 3rd term in my final answer. What do I need to add to negative 3 to get negative 11? I'm going to take negative 11 minus negative 3 is negative 8. So I have negative 8x to the 3rd now. Next I'm going to think, what do I need to multiply by 2x to get negative 8x to the 3rd? Well, it's going to be negative 4x squared. Negative 4x squared times negative 1, that's positive 4x squared. Now I don't see an x squared term. What is it that I would have to multiply by x squared to make that term disappear? Well, a 0. Right? Invisibly, there is a 0x squared term in here. It just doesn't do anything, so we usually don't write it. Right now we need to use it, so we're going to actually write down 0x squared. What do I need to add to 4x squared to get 0x squared? I'm thinking 0 minus 4 is, of course, negative 4. Okay, now I've got a negative 4x squared here. What do I need to multiply by 2x to get negative 4x squared? Well, negative 2x. And then negative 2x times negative 1, that is positive 2x. For my x term, I need to get positive 8x. So I'm thinking 8 minus 2 is 6. I'll need to have a 6x here. And finally, what do I need to multiply by 2x to get 6x? Well, it's just a 3. 3 times negative 1 is negative 3. I want to have a negative 3 for my constant term, and I do, so that really was a factor. My division then gives me what I read across the top. 3x to the third minus 4x squared minus 2x plus 3. I'm going to give you one of these to try. Divide these polynomials. Pause the video and try this now. Okay, so we begin by setting up just the first column of a factoring frame with our divisor off to the left, and the first term of our dividend in the first box. Then we say 3x times what gives us 3x to the third? Well, 3x times x squared gives us 3x to the third. X squared times 2 is 2x squared. For our x squared term, we want negative 10x squared. And so we're thinking negative 10 minus 2 is negative 12. In this box here, we'll want a negative 12x squared. Next, we're thinking 3x times what gives us negative 12x squared? Well, it'll be a negative 4x. Negative 4x times negative 2 is negative 8x. For our x term, we want to have negative 11x. So we're thinking negative 11 minus negative 8 equals negative 3. Here we'll have a negative 3x. And finally, 3x times what gives me negative 3x? Well, this must be a negative 1. Negative 1 times 2 is negative 2. We wanted a negative 2 for our constant term, so that works out. Our division then gives us what we read across the top. X squared minus 4x minus 1.